All right, so we're still talking about roots and going to learn how to switch in between the two forms. So there's exponential form and root form. So you'll notice up here at the top, this is how you go in between the two. So if you have a to the x power and then like the y out here is like the cube root or the fourth root or whatever, you can rewrite it as a to the x divided by y. So we're just going to practice switching in between the two forms right here. So on this first one, how would we write this? 25 to the what? 3/4. Okay, so that number on the outside is always your denominator. Okay, what would this one be? 6 to the 5/2. Remember, if there's no number out there, there's really a 2 because you're looking for groups of 2. And then x to the 7/3. There's a couple variations that I want to talk about here. So looking at this, even if the 4 is on the outside, it's not underneath with the 5, it's still going to be 4/3. So this would be 3/4. And then let's look at this one. We've got 1 over 5 to the what? 1/4. Or another way to write that is 5 to the negative 1/4. So remember, negative exponents move things. So if it's on the bottom, that means it started out with a negative exponent. What's this one? All right, so now switching to the other form. If this is negative, what does that mean? Okay, so we're going to have 1 over something. What's the big number going to be? We've got 4. What's the outside? There's a 2 there, so we don't need to write it, but I won't count it wrong if you put the 2 out here. And then we've got 5 right here. What's this one? Okay, so we have a y here. You can put a 1 right here as an exponent, and you can put a 2 out front of the root, but you don't have to. Okay, so if you wrote this, I wouldn't count it wrong, but you wouldn't need them there. Okay, so this one, we've got 5 raised to the, and then we've got the 2 out here, which we don't need to write. You'll notice that the one that's closest to it is going to stay closest to it. That's an easy way to remember it. Okay, so we've got 7 to the 1 with a 4th root on the outside. And then this is another negative 1, so it's on the bottom. 15 to the 1 and the cube root of that. Okay, so this was simply just practicing changing in between the two. Yes, there are some on here that could be simplified further, but that's not what we're talking about right now on this page. Make sense on how to go between the two? Okay, now we're going to talk about something called base numbers. We're not going to write anything on this page per se, but know that there are an infinite number of base numbers because these lists could go on forever and ever. So if we had 1 to the 4th power, it's still going to be 1. If we had 10 cubed, it'd be 1,000, so on and so forth. So all of these lists would continue to grow forever, but these are just the most common ones that you're going to see. So that's why I listed all of these. Now, base numbers mean that the number, the big number here, like this 3 for instance, is a prime number. Okay, so we can't have 4 as a base number because 4 could be broken down to 2. So base numbers can't be broken down into other numbers. So I shouldn't have said they were prime because 6, for instance, isn't prime. But 6 is a combination of 2 and 3, but we're going to skip 4. Why would we skip 9?
Because it can be broken down to 3 thirds.
3 and 3. Okay. We're also going to skip 8 because that can be 2, 2, and 2. Okay, so the base numbers are just these right here, and these are the most common. But obviously another one would be like 13. Okay, these are the ones we're going to use the most in the homework. Okay, but we just need to know when I say use base numbers, this is the list I'm talking about. So here's what I mean by those problems. So it says evaluate by using base numbers. Here's how we do this. The steps are the same every single time. So when it says base numbers, what they want you to do is to change this number into its base number. So 100, what's the base number for 100? 10 squared. Okay, we still have this 1/2 right here, so we keep the 1/2 on the outside. What do we do in this situation? We talked about this in our last chapter. What do we do with the 2 and the 1/2? Yeah, we multiply them when it's a power raised to a power. So that would be 10 to the 1, which is 10. So it's these same 3 steps every single time. Okay, so we go to 64. What's the base number for 64? It's going to be somewhere on this list, right? 2 to the 6th is 64. Okay, so what are we going to do here? It's really 2 to the 3rd, which is 8. Okay, yes, I know that you could easily just put it into your calculator, 64 raised to the 1/2 power, and get 8, but I want to know that you know what base numbers are because they're going to help us in the next chapter. Okay, so this process is important. Okay, 27 is what? 3 to the 3rd. So we change 27 to its base number. We multiply the exponents. So we get 3 to the 1, which is 3. 243. Is that on our list? Which one would you guess it would fall under that we could try? Somebody have their calculator out? Okay, so somebody check the 3s, keep going up, and then somebody check the 7s. See if you can find it. We're looking for 243. So we want 7 cubed, and we want 3 to the 5th. What do we get? 3 to the 5th? Did anyone check this one? So that we have it on our growing list. 7 to the 3rd power. Okay. So we found 243 right here. So that was 3 to the 5th power. We keep the 1/5 on the outside. We multiply our exponents. And we get our answer. All right, let's try these guys. We've got 125. What's the number there? Yep, 5 to the 3rd. We multiply these exponents, and we get what? We get 2. 5 squared is 25. Okay, we'll change this one to its base number, 10 squared. We multiply our 2 exponents, and we get which is 1,000. It may seem strange that we have to go through this process just to get these answers, but I promise you that knowing these base numbers is going to help you so much in the next chapter. All right, so 36 is 6 squared. We got negative 3 over 2. We multiply these guys. Negative 3. So that's going to be 1 over what? What's 6 to the third power? Okay, so there's your answer for that one. And the last guy. We've got 3 to the what? I think it's the fourth. We multiply these two numbers. And we get what? Negative 3. Okay, so that means we've got 1 over 27. Questions? Okay, so in the homework you're going to see a spot where it says evaluate using base numbers, and these are the steps they're looking for. We're good? All right, let's get into some tougher problems. So you have some examples when you get to the homework. Now, I'm going to have you keep all of your answers in radical form. So if they're in exponent form, like these first 3 right here, we're going to end up switching them over to radical form, which you know how to do because we did that on the first page. But let's talk about what our exponent rules are in this situation. So up here on top, if we multiply these two together, what would we do with our exponents? We add in that situation. Okay, so what's 3/4 plus 1/2? 1 1/4 or 5/4. Okay, so if you take 3/4 plus 1/2, we get 5/4. Okay, your calculator can tell you that. Okay, but we need to write this in radical form. So this would be what with the x? What goes on the x? 5. And our 4 goes out here. Okay, now we need to simplify if we can. So what size groups are we looking for? Size of 4. Do we have 4 x's? Yes. Okay, so we can take one of those out. And we're left with how many left over? Just 1 x is left over because we took a group of 4 out of those 5 x's. You're just left with 1. Okay, what's our rule with exponents if we're dividing like this? We subtract them. So what's 4/5 minus 1/5? 3/5. Okay, so all we have to do is switch it over to radical form. What number's on the outside? 5. And we've got s to the third. Do we have a group of 5 in there? No, so that's as simplified as it goes. All right. This one, if it's a negative, that means what? It's going to move, right? Okay, so we've got 1 over b to the 5/7. So let's switch that to radical form. Looks like we've got the 7th root of b to the 5th. Now we learned in our last section that we can't have radicals on the bottom. First of all, can we simplify that at all? How many more b's do we need in order for this root to go away? 2 more. Okay, so that's what we're going to multiply top and bottom by. So we've got the 7th root of b squared, 7th root of b squared, and now we'll multiply straight across. So we're timesing here, timesing here. On the top we just get 7th root of b squared. But now that we have a total of 7 b's right here, they all come out of the root, right? Because we're looking for a group of size 7, so we just get b. So remember, we're just trying to make sure there's no roots on the bottom. All right, this last one, we have different roots. We have a fourth root and a square root. Now when they're different roots like that, we can't combine them. So sometimes it's easier if we switch it over to exponent form just for a little bit. So if we were to switch this to exponent form, what would this be? 27 to the 1/4. Okay. And down here we've got 3 to the 1/2. Now we still can't put these together because the 27 and the 3 are different. But we learned today about base numbers. So we could change 27 to be what? 3 to the 3rd. Okay. So what do we do here? We multiply. So let's rewrite this. So instead of 3 to the 3rd to the 1/4, we have 3 to the 3/4 divided by 3 to the 1/2. So now, just like we talked about up here, what do we do with our exponents? We subtract them. So what's 3/4 minus 1/2? Just 1/4. If you have 3/4 of something and you take half away, we're left with 1/4. So we've got 3 to the 1/4, but I told you to keep them all in radical form, so now I just got to switch it back over to what? The exponent is 1, the root is 4. So I went a little bit quickly through that, so I'm just going to recap. We switched it to exponent form, changed to the base number, simplified the base number, subtracted the exponents, changed it back to root form. Okay, so if your original problem like this, you can't put them together, odds are if you switch it over to exponent form and then change it to base numbers, you will be able to. Questions on those? These will be very helpful when you have the homework side by side to have a kind of a step-by-step example. All right, last page. Looking at these ones. All right, so right now we're looking for groups of size 4. Do we have any groups of size 4? No. Okay. Let's see what happens here if we switch it over to exponent form. So if we did that, we've got 9g squared raised to the what power? 1/4. Okay, you could think of this whole thing as having an exponent of 1. Okay, what do we do in this situation when we have parentheses and we've got an exponent on the outside? Do we make sure everything gets raised to the 1/4 power in the parentheses? Yes. Okay. So if we rewrote this, this would be 9 to the 1/4 and g to the what? I'm hearing a few different numbers, so I want to make sure. What do we do with these two? We multiply them. So what's 2 times 1/4? 1/2. So we got 1/2 right here. Now we talked about base numbers today. Can we change 9 to a base number? Okay, so let's do that. So that's the only thing we're going to change right here. We got 3 squared. We got 1/4 out there. G to the 1/2. So again, we've done this multiple times in the notes today. We're going to multiply here. So on our next step, that's the only thing I'm going to change. So we've got 3 to the 1/2, g to the 1/2, which if we put this back together underneath a root, so this could be written as 3g to the 1/2, what would it look like? Got 3g here, exponent 1, number out here 2 in front, which you don't need to write. Okay, but you can if you want to. questions. It's using everything we've learned today all in one problem. How did I get what? Where?
Nope. Nope. Yes.
Right here? Oh, from 9. 9, the base number for 9 is 3 squared. Good question. Okay, we're going to do something similar with this next guy. Okay, so if we look at this and we change it to 64z to the 6th, what would it be raised to? 1/3. So now we're going to raise both of them to the 1/3 power. So we got 64 to the 1/3, and we've got z to the 2. Change the 64 to its base number, which is what? 2 to the 6th. So we've got, so we'll multiply here again, and we get what there? So we got 2 to the 2 and z to the 2. This is a good example of why I put lines through my z's so you can tell which one is which. So what's our final answer going to be? Four z squared. No root at all because there's no fractions in our exponents. Okay, could you have also done what we did in our previous section where we take 64 and go 2 z6? Absolutely. Okay. All right, last one. Let's switch these over to be roots right away. So this is really going to be what? Square root of x? Okay, you don't need to have the 1 exponent. You don't need to have the 2 out front, but you can. Plus 1. We got the square root of x minus 1. This gives us another opportunity to practice doing this. We talked about this in our last section, actually. How do we get rid of that root on the bottom? We can't just multiply by square root of x. What do we have to do? We have to multiply by what's called the conjugate, square root of x minus 1. So you take that denominator and you rewrite it, but you change the sign. We need to multiply by that same thing on top and bottom. So on the top, we'll multiply, and on the bottom, we'll multiply. So you can think of this, these are our two fractions here, our two numerator and denominator. So on the top, we've got, and on the bottom, we'll do that. All right, so right here, what's square root of x times square root of x? And we just get x. Here we get minus square root of x, minus square root of x, and positive 1. Okay, on the bottom, we'll get x, square root of x, minus square root of x, and negative 1. So on the bottom, these two are gone. They cancel out, which is good because we want to get rid of the root. That was the whole point. So looking at our answer here, what do we have on the bottom? Yeah, we just got this x minus 1. No more roots on the bottom. And on the top, when we combine like terms, we've got x minus 2 root x plus 1. Questions on that process? Again, having these side by side with your homework, you're going to have a step-by-step process to follow for solving each of them.